Hi students and friends, welcome to the channel Learn and Teach by Sir Ayaz. So I will continue my video lesson for CAIE 5070 past paper, and the paper I was doing was paper 22 for October, November, winter 2022. I left question number question number 4 part E. So I'm going to start this video with question number 4 part E. Ammonium sulfate decomposes when heated. The reaction is endothermic. This is the reaction. It's a decomposition reaction. And here are the products. Complete and label the energy profile diagram for this reaction to include the reactant and the products, the enthalpy change of the reaction. So this reaction is endothermic, which means that product will be at the high energy state. So we'll start from this side. The energy hum will go up. Now, let's show the reactants and product. So reactants will be 3NH4, 4 twice SO4. The products will be 4NH3 plus 3SO2 plus N2 plus 6H2O. The second part, they are saying enthalpy change of the reaction. The enthalpy change should be between reactant and product should be this. So we'll write enthalpy change. Number five, this question is about metals and metal compounds. A. Zinc reacts with aqueous copper 2 ions. Zn plus Cu2 plus gives Zn2 plus Cu. Explain why this reaction involves both oxidation and reduction. Use the equation and ideas about electron transfer in your answer. So write zinc is oxidized, or oxidation of zinc. Zinc is oxidized because it loses electrons. As you see the charge on the zinc on right hand side, it is +2, which means it has lost electrons. And copper changing from +2 to 0, which means it has gained electron. So you write copper 2 ions, copper 2 ions is reduced because it gained electrons. B. Aqueous ammonia is added to aqueous zinc ions. Describe the observations when few drops of aqueous ammonia are added. We will get white precipitates. White precipitates. Excess aqueous ammonia is added. Precipitate dissolves or colorless solution. Precipitate dissolves or colorless solution. C. Molten zinc chloride conducts electricity. Number 1, predict the products formed at the anode and the cathode when molten zinc chloride is electrolyzed. Zinc chloride, in zinc chloride, the formula of zinc chloride is ZnCl2. It contains Zn plus 2 ions and Cl negative ions. So Zn2 plus will gain electrons or take up electrons to form zinc or Zn at cathode. So you write zinc, or you can even write the symbol for zinc. While at anode, chloride ion will lose electrons to produce chlorine gas, or you can even write Cl2. Number 2, explain in terms of structure and bonding why zinc chloride has a high melting point. So you have to refer the structure. So you write ionic lattice, giant ionic lattice, strong forces of attraction. Between positive and negative ions. D. Aluminium is extracted from its ore by electrolysis. Number 1, state why aluminium is extracted by electrolysis and not by reduction with carbon. Simply, it's more reactive or high in the reactivity series. Aluminium is highly reactive, high in the reactivity series. Number 2, state one property of aluminium which makes it suitable for the construction of aircraft. It's light or low density. Number 3, state one advantage of recycling metals such as aluminum and copper. We conserve these ores. Conserve or save ores. Section B. Answer 3 questions from this section in the spaces provided. The total mark for this section is 30. Number 6, this question is about nitrogen and oxides of nitrogen. A, state the percentage of nitrogen by volume in dry air. You have to learn it by heart. The percentage of nitrogen in dry air is 78%. So you write 78%. B, the equation represents the equilibrium between nitrogen and oxygen at high temperature in a closed container. N2 plus O2 gas gives 2NO gas. Number 1, predict what happens to the position of equilibrium when the pressure is increased. Explain your answer. So whenever you increase the pressure, the dynamics of the equilibrium or direction of the equilibrium will shift towards the side with less number of moles. So if you count the number of moles here, so on the right hand side, on the reactant side, it is 1 plus 1, which will be 2 gives, and on the product side, again 2. So the number of moles are same on both the sides, so there will be no effect on the position of equilibrium. No effect. And reason will be simple. Same number of moles of gases on each side of the equation. Number 2, the table shows the concentration of nitrogen 2 oxide NO in the closed container at 3 different temperatures. These are the temperatures: 800 degrees centigrade, 1000 and 1200. You see the concentration of NO in mole per dm cube is increasing. At 800 degrees centigrade, it was 0.02, but at 1000 degrees centigrade, it will raises to 0.2, and at 1200 degrees centigrade, it reaches to 20 mole per dm3. State what this information shows about the enthalpy change of the forward reaction. Explain your answer. Enthalpy change, endothermic. So the explanation will be higher concentration of NO. Higher concentration of NO at high temperature. You can even refer the concentration of O2 and N2, which will be lower concentration of O2 and N2 at high temperature. C. Nitrogen 2 oxide NO reacts with hydrogen to produce ammonia and water. Construct the equation for this reaction. So NO plus H2O. Sorry, this is H2, not H2O. Ammonia NH3 plus water H2O. Now let's balance the equation. Hydrogen is not balanced. On right hand side, it's 5. So first of all, we'll convert. If I will place 2 here, 2 multiplied by 2 is 4. 4 plus 3 is 7. Again, it's not balancing. So I will write 2 before NH3. It's 2 multiplied by 3 is 6. And 2 by 2 is 4. 6 plus 4 is 10. So I will write 5H2. What about nitrogen and oxygen? Both nitrogen and oxygen are 2. So you'll write 2 here. 2 before NO. Number D, nitrogen oxides are pollutants in the atmosphere. State one source of nitrogen oxides in the atmosphere. Vehicle engines, or car exhaust, fumes, or fossil fuel powered. Fossil fuel powered stations. Number 2, nitrogen oxides contributes to acid rain. State one effect of acid rain on buildings. You can write erode or corrode. Number 3, state the formula of the ion that is present in all acids, that is H positive ion. This question is about carboxylic acids and polymers. A. The structure of an organic compound is shown. Deduce the molecular formula of this compound. So let's start counting with carbon. We have 1, 2, 3, 4. 4 carbon atoms. So you'll write 4 here. What about hydrogen? 1, 2, 3, 4, 5, 6. So H6. Oxygen. 1, 2, 3, 4, 5. So you have 5 oxygen here. So the final formula will be C4H6O5. B. Propanoic acid C2H5COOH reacts with methanol CH3OH to form an ester. Name this ester. Draw the structure of this ester showing all atoms and all bonds. Name of ester, the structure of ester. So how are you going to deduce the name of ester? The other name for ester is alkyl alkanoate. The alkyl group will be coming from methanol. So you will get methyl. So methyl. Alkanoate will be coming from the carboxylic acid, which is propanoic acid here. Propanoic acid gives alkanoate. So we have propanoate. Methyl propanoate. Now structure of the ester. We can start with the methyl group. For methyl group, we have CH3. This will be CH3 joined by oxygen. Then you have propanoate coming. C double bond O. 1, 2, 3. Now I'm placing all hydrogen atoms. This will be the displayed formula for methyl propanoate. Alternatively, you can start with the propanoate. So you'll have 1, 2, 3. Now you have methyl ion, methyl group. Now I'm placing all the hydrogen atoms. Number 2, state 1 use of esters. You know that it's used as solvent, perfumes, flavorings, solvents, perfumes, flavorings. C. Ethanoic acid can be produced by the bacterial oxidation of ethanol. Give one other method of oxidizing ethanol to produce ethanoic acid. Can have acidified potassium manganate. Acidified potassium manganate. After potassium, for potassium manganate, you'll write 7 here. You can write KMnO4 for potassium manganate. D. The simplified structures of a dicarboxylic acid monomer and a diamine monomer are shown. This is dicarboxylic acid, and this one is diamine. Number 1, draw the partial structure of the condensation polymer formed from these two monomers to show 2 repeat units, all of the atoms and all of the bonds in the amide linkages. So you have to show 2 repeat units, which means you have to show 2 amide linkages. So I will start with the dicarboxylic acid. Recall that amide linkage will be C double bond O NH. Now I have a diamine monomer coming. It's again combined to another dicarboxylic group. This will be the final displayed formula. State the meaning of the term condensation in condensation polymerization. When you say condensation, there's joining of 2 compounds with elimination of a small molecule like water. Joining of 2 compounds with elimination of a small molecule like water. E. Proteins have amide linkages. Proteins are hydrolyzed using dilute acid. Name the type of compound produced by this hydrolysis. You know, proteins are the polymers made from amino acids. So you will get amino acids on hydrolysis of proteins. Question number 8. This question is about metals and metal compounds. A. Describe with the aid of a labeled diagram the structure and bonding in metals. So you know the metallic bonding in metals. So you have to show at least 3 layers. Will be like this. 1, 2, 3. This will be metal cations. This will be metal cations. Now I'm showing the free electrons. These will be free or delocalized electrons. Free or mobile or delocalized electrons. So write closely packed positive ions. Closely packed positive or metal ions. Strong attraction between the metal cations and delocalized electrons. Now, these particles are surrounded by sea of delocalized electrons. Particles surrounded by sea of delocalized electrons. B. The table shows the reactivity of 4 metals with cold water and with steam. Metal, cerium, nickel, rubidium, zinc. This table is shown here. Put the 4 metals in order of increasing reactivity. First of all, we'll see the least reactive. So nickel looks least reactive because it's not reacting with cold water and it's reacting very slowly with steam. So we'll write nickel in the first box. And in the next box, you can have zinc because it's also not reacting with cold water, but it's reacting fast with steam. So you'll write zinc here. Now we are left with cerium and rubidium. Cerium is reacting slowly with cold water, but rubidium is reacting very fast. So you must have cerium, and in the end, you will get rubidium. So this will be the final order. See, the full symbol of an ion of cerium is shown. This is a symbol for the ion of cerium, Ce plus C3 plus. Deduce the number of electrons and neutrons in this ion. So 3 plus means it has lost 3 electrons. So what you will do, you will subtract 3 from 58. So what you will get? You will get 55. So you'll write 55 here. What about the number of neutrons? You have to subtract 58 from 140. Should be 82. D. Zinc reacts with aqueous silver nitrate AgNO3 to produce aqueous zinc nitrate and silver. Construct the ionic equation, including state symbols for this reaction. Now you have to construct the ionic equation for this reaction. The reaction will be this: Zn solid plus AgNO3 aqueous gives ZnNO3 whole twice aqueous, because zinc carries +2 charge and nitrate ion carries -1 charge, plus Ag solid. So let's balance the equation first. We'll cancel out the spectator ions on both sides of the equation. We'll get nitrate ion being cancelled. So we'll get ZnS plus 2Ag plus aqueous gives Zn plus 2 aqueous plus 2Ag solid. E. The effect of heat on crystals of green nickel 2 chloride NiCl2 6H2O is shown in the equation. NiCl2 plus 6H2O green gives NiCl2 yellow and nickel 2 chloride plus 6H2O. Number 1, state the term used to describe salts such as NiCl2 which contain no water of crystallization. It's very easy, it's anhydrous. Number 3, describe how to change yellow nickel 2 chloride back to green nickel 2 chloride. Add water. (9a) Magnesium carbonate reacts with dilute hydrochloric acid. MgCO3 plus 2HCl gives MgSl2 plus CO2 plus H2O. When 25 centimeter cube of dilute hydrochloric acid is added to excess magnesium carbonate, the volume of carbon dioxide gas produced at room temperature and pressure is 120 centimeter cube. Calculate the concentration in mole per dm cube of the dilute hydrochloric acid. For this, we need the moles of hydrochloric acid, and the volume of hydrochloric acid is provided to you. We have volume of HCl, which is 25 centimeter cube, and the volume of CO2 is also provided, which is 120 centimeter cube. We know that at RTP, all the gas occupies a volume of 24,000 centimeter cube. Gases at RTP occupies 24,000 centimeter cube. So you'll divide 120 by 24,000 in order to get the moles of carbon dioxide. 120 divided by 24,000, you will get 0.005 moles of carbon dioxide. The relationship between hydrochloric acid and carbon dioxide is this: CO2, hydrochloric acid, 1 mole CO2 produced from 2 moles of HCl, therefore 0.005 mole produced by X moles of hydrochloric acid. So it will be X is equal to 2 multiplied by 0.005. So we will get 2 multiplied by 0.005, 0.01 moles of hydrochloric acid. So if 25 centimeter cube contains 0.01 moles of hydrochloric acid, so therefore 1000 centimeter cube contains X moles. So it will become X is equal to 0.01 multiplied by 1000 and divided by 25. 0.01 multiplied by 1000 divided by 25. 0.4 mole per dm cube of hydrochloric acid. Number 2, the reaction is repeated at higher temperature. All other conditions stay the same. Describe how the rate of reaction changes. Explain your answer using ideas about collisions between particles. It's very easy. High temperature means rate increases, but it will not help you. You have to give the explanation also in terms of the uh, energy of the particles. Particles have more energy or more kinetic energy, have more kinetic energy. After that, you will write about the collision between the particles. More successful collisions. There will be more successful collisions. Or you can even write more particles have energy greater than activation energy, or more particles have energy greater than activation energy. Number 3, the reaction is repeated using a higher concentration of hydrochloric acid. All other conditions stay the same. Describe how the rate of reaction changes. Explain your answer using ideas about collisions between particles. Again, the rate of reaction will increase. So you write rate increases. But you need to give explanation also. This time particles, there are more particles per unit volume. So you write more particles per unit volume. And there will be greater collision frequency. Number B, human is an alloy of aluminium, magnesium, copper, and manganese. State the meaning of the term alloy. It's a mixture of metals. You can write with other elements, because sometimes you have carbon also, like in alloy of steel. C, copper is purified by electrolysis using an impure copper anode and a pure copper cathode. Construct the ionic equation for the reaction taking place at the cathode. At cathode, the copper ion will take up electrons. So you write Cu plus 2, or 2 plus 2 electrons gives Cu, copper. 9D, a metal object can be electroplated with another metal. State one use of electroplating. It makes the object harder, surface, or become more resistant to corrosion. More resistant to corrosion. Thanks for watching. Press like, share my videos. For more videos, subscribe to my channel and press the bell icon.